when the numerator and the denominator have no common factors, which means you can't take out a GCF, you can't factor them into binomials and cancel something out, then we say that that is simplified or reduced to lowest terms. So if I say simplify or reduce to lowest terms, it means factor out any common factors and reduce it down as small as possible, and that's where factoring is going to come back into play. And then we can also multiply and divide these and simplify them. So I have to admit that I kind of love doing rational expression. It's one of my favorite things where you get to factor and cross things out, and it's just kind of fun for me. Some math is so fun. But factoring and canceling, kind of fun for me. But there's a lot of common mistakes on this, and we're going to kind of go over these rules here today before we get into it of how do you simplify and what are the rules that you need to follow. So we'll see what we can get through today. And then we'll get into adding and subtracting, but not today. Okay with me going on? If I go, no, okay, I'll wait a minute. I forgot to be special person of the day or something yesterday for being so good.
He was line leader, and we got to be,
Oh my goodness, very sad. For being good, like he's good now. Like he's turned over a new leaf.
I'm doing this bumper stickers, but it's going to say like my son's the line leader.
My son's a line leader. But he told me being line leader isn't that cool because line leader has to just hold the door open. So you don't really get to be the line leader.
So you want to be second.
Yeah, you want to be second in line because line leader opens the door and then ends up in the back of the
Glad
line.
you go to one.
Second, yeah. I think it's just line leader. I don't know how they line up after that. Everybody okay with me going now? Yes, no, yeah. All right. So, when we're talking about simplifying, we want to be aware of the cancellation property. So I kind of tried to summarize this so you didn't have to write so much. But basically, you want to factor the numerator and the denominator. And then you can cancel like terms. The big thing you want to remember about the cancellation property is that you can really only break things up when they're multiplied. I think I wrote that down here. But if I have A times C divided by B times C, that's multiplication. If they both have a common factor of C, then I can cancel those out. And that's the same as saying A over B. You don't have to write all those exclamation marks. But this is the big thing when you're doing this. You cannot cancel out, like break up addition and subtraction, unless you're canceling out the entire sum or difference. So I'm going to kind of give you an example of that. If you had A plus B over A plus C, right? That's very different than that one. This A plus B is one factor together. They never get separated. The only way I can cancel out A plus B is if I have the exact same thing in the bottom, another A plus B. And for some reason, people just get cancel out crazy when we do these, and they just cross out those A's, and then they're just left with B over C, which is not okay. This is just, you can't do anything with it. Like, that would just be your answer, because you cannot break up addition and subtraction. So I like to say multiplication, they're just dating. It's easy to break up. Addition and subtraction, they're married, and they're like old school married, really hard to break up. I know you can get a divorce, but there's paperwork and there's, lots of things to think about. Addition and subtraction are stuck together. It's just easier to stay together than break up. All right, so I don't have a better example than that because I know marriage can be broken up too, but we're going to say like old school married where you're just stuck. Okay? So, part of your homework today is just simplifying, so let's do a couple of those. King and queen married. The king and queen they kill each other. Behead the wives.
You told your son you have to make it
Oh yeah, like prearranged marriages.
Yeah.
If you have a prearranged marriage, you're probably not going to get a divorce.
Once one dies. Oh, she actually did die.
Okay, so the first part of your homework today is just going to give you a rational expression and ask you to reduce it. And the big thing that you have to remember is you have to factor first, because right now I can't do anything. I can't cross these x squareds out because there's addition there. I can only cancel out multiplication, so that's why we factor. So that's why the quiz was so important that we just took. I'm going to rewrite it down here. I'm going to factor the top and factor the bottom, and hopefully something will cancel out. Usually it does. If it doesn't, then you might want to go back and check your factoring. Could there be one that nothing cancels out? There could, but I'm guessing probably not. So I started off here with just some nice ones with this x squared in the front, where you just get to say what multiplies to give me x squared, x and x. What multiplies to give me 4, that adds to give me 4, plus 2 and plus 2. And on the bottom is x and x. What multiplies to give me 2, that adds to give me 3, plus 1 plus 2. Everybody with me on that factoring there? And then, once you have it in the multiplication, that's when you can do your canceling. And you can cancel out x plus 2, since there's an entire x plus 2 down here. I'm not separating them. I'm canceling out the entire thing. And your answer is just x plus 2 over x plus 1. Questions about that? Oh man, there's 2 more. I can't let you see too much at once. How about this one? Those lovely cubes that we just did. You want more writing? We're going to get there. As we get into more of this, you're going to see that it is more similar to the second half of algebra 2, which is definitely more stuff. Fundamental theorem of algebra, solving those polynomial functions. We'll get there. But right now, yeah, there's not a whole lot of writing, like not a whole lot of definitions or theorems. It's just solving problems. This one, again, what we just took a quiz over is coming back. We want to factor the top and factor the bottom. The top is a perfect cube, right? You could rewrite this as x cubed minus 2 cubed. And so again, those formulas are still going to be useful for us. On the top, remember that's going to factor into a minus b, and then the next one. So remember, this number is a and this number is b. So a minus b is going to be x minus 2. And then a squared is going to be x squared plus, I always go back to this one because this is a and this is b. So it's this one squared plus this times this, which is just going to be 2x, plus the last one squared, which is 4. And remember, that can never be broken down anymore, so that's as far as you're going to go on that. And what about the bottom? What can you factor on that one? I can factor an x out. Can I factor more than one x out? Yeah, I can factor an x squared out, and that's like the GCF. And if I take an x squared out of x cubed, I'm left with an x and a minus 2. And again, usually a good hint that you're doing this the right way is if you have something that you can cancel out. So I could cancel out x minus 2 and x minus 2. And make sure you write your answer. Like, don't leave your answer like this for me to grade. That's just a mess. Rewrite it very nicely as x squared plus 2x plus 4 all over x squared. And then I'm going to cross those x squareds out, right? No, because I can't break up addition subtraction. People do it every time, though. Like, I have to emphasize it because every time people just get cross out crazy is what I like to call it. I'm trying to give you some different options here of different ways I can give you to factor on these first 3. So what do you think about that one? 8 minus 2x over x squared minus x minus 12. the bottom I can definitely see is that trinomial, right? And I get, I'm going to do the bottom first. Yeah, well, multiplies to give me 12, that subtracts to give me negative 1. Well, 4 times 3 is 12. And if I make the 4 negative and the 3 positive, that'll give me a negative in the middle. So x minus 4, x plus 3. On the top, do you agree we could pull a 2 out of that? But I'm going to write it up here just to kind of show you. If I just pull a 2 out of this, I would be left with 4 minus x. Well, maybe I'll write it here so you can see it. 2 times 4 minus x. Is this parenthesis the same as this parenthesis? They're very close, but they're not the same because this one has a positive 4 and a negative x, and this one has a positive x and a negative 4. And so sometimes they're going to give you things like that, but we can still make them work. What could we do to this to make it have a negative 4 and a positive x? Yeah, yes. And then once you do these, you can just pull out a negative 2 to begin with. But if you ever don't take out the negative and you see that these are opposite, you can just pull a negative out. And so instead of taking a 2, what we're really going to do is take out a negative 2. And what that does is it's going to change the sign of these. I like to switch where they are too so they match up. So if I change the sign of 4, that's now going to become a negative 4. And if I change the sign of negative x, it's going to become positive x. You don't have to flip it around. You could just write it as negative 4 plus x. But I like to rewrite it. And yes, by all means, if you notice right away that it's backwards, you can pull a negative out to begin with. But now those are going to cancel out. And this one would simplify to negative 2 over x plus 3. I am recording. Okay? So, simplifying. What else can we do with this? We can multiply and we can divide, because then we get to multiply, divide, and then simplify again. So it's kind of just adding in a little extra work. More fun, if you want to say it. There's certain things in math I don't enjoy doing, but I just like doing this. I like factoring. I like canceling stuff out. Cross multiply. No. I don't know. We'll see. See if that's what you're talking about. Proportion, maybe you're thinking of. So I thought I'd give you the rule here in case you forget about multiplying and dividing fractions. That's what rational expressions are. When you multiply fractions, you can cross things out, you can cross cancel, but the real rule is when you multiply fractions, you just multiply straight across the top, straight across the bottom, and then cancel if you can. Or cancel, yeah. So A over B times C over D is just A times C over B times D. Obviously, the ones I'm going to give you are not going to just be A over B times C over D. You're going to have to factor and simplify, but at the end, you just multiply across. And then dividing fractions is what people forget. And they are going to write them like this for the most part. It's like a fraction in a fraction. So A over B divided by C over D. And remember that this fraction bar is just a division sign, right? And how do you divide fractions? You multiply by the reciprocal. So to leave the first fraction alone, you change your division to multiplication, and you multiply by the reciprocal. So you're never actually going to divide, because when you divide, you're really just multiplying by the reciprocal. So this would be the same as A times D over B times C. And again, we're going to do some with actual problems in a minute. You can do the cross-canceling as well, but you want to make sure you remember to multiply by the reciprocal first. Okay, so we're still going to factor, we're still going to know how to cross out, but then the only extra step is we're going to multiply and divide. Are you okay with that? Alright, let's do another one. You don't have to write this whole thing, but I just wanted to show you that this is what your homework says. You can just put simplify on your paper, but this is what your homework says. It says perform the indicated operations and simplify. Leave your answers in factored form, which means they don't want you to multiply your answers back out at the end, and it actually saves you some time to not multiply it out. And I'll show you as we work through it. But you could just write simplify and write the problem. So now we have a rational expression x squared minus 2x plus 1 over x cubed plus x times 4x squared plus 4 over x squared plus x minus 2. So again, maybe you can see why we spent 3 days on factoring before we did this section, is you got to know how to factor in order to do these problems correctly. And so step 1, you got to factor everything. We can't cross anything out because it's addition and subtraction right now, but we can make it into multiplication. So I'm just going to go through, and if this was my paper, if I had room above it, like I might just factor it up here and factor it below, like instead of rewriting it every time, and I'm okay with that as long as we can read it, but I don't have a lot of room up there, so I'm just going to rewrite this on the top. And hopefully you're factoring at the same time as me, so we'll just kind of see if we agree when we're done here. How about that? Alright, GCF up here, I can take out a 4. And then I can factor this. So you can see where if you factor wrong, the whole thing's going to be wrong. So again, if you need some more help with factoring, make sure you see me about that because factoring is really important here. This one I want a positive 1, so plus 2 minus 1. Kind of check your factoring with my factoring. Let me know if you have a question on where I'm getting any of this from. If you wanted to, you can multiply straight across here. But the idea is that we're going to be able to simplify. So remember that you can simplify top to bottom like we just did, like anything on the top that cancels out with the bottom. But that also works diagonally. Anything that cancels up here with down here, like that also works. So you can cancel top to bottom, or you can cancel from the diagonals, and you can cross out anything that looks exactly the same. So anyone have a question about my factoring before I start canceling? So what can I cancel out? I can cancel out this entire x squared plus 1 with this x squared plus 1. And I can cancel x minus 1. Doesn't matter which one you cancel with, just one of them up there. And I think that's all we can cancel, which means what I have left with now, I'm just going to multiply across 4 times this. Leave in factored form means they don't want you to put the 4 in there. They just want you to write that as 4 times x minus 1. And on the bottom, we have an x and an x plus 2. And they want you to leave your answers like that, which actually saves you work. You don't have to distribute and simplify it. Questions about that? No. Usually we like them left like that. Especially if we get to, when we're solving these, like setting equal to 0, it's much easier if they stay factored. If you do, I have graph paper. I'm that nice of a gal. Oh, this fun one. It's just factoring. Factoring is fun. Did you have like, ruined my back on second grade when you have like time tests? Should be like time factoring. I would rock it.
I set it up so
That's why you're not a teacher. Again, if you factor this and nothing cancels, it's kind of a nice thing because it tells you that maybe you missed your signs up. You have x plus 2 up here, but down here you have only an x minus 2. Maybe go back and look at it. It kind of helps a little bit more than on the quiz. You didn't have anything to kind of check yourself as you were doing it. And again, notice these actually aren't that bad. None of them have a number in front, so you don't have to do the factor by grouping. So that helps a lot. A couple every now and then might have a factor by grouping in it. I think I gave you 1 minute for the division work. But for the most part, they're not terrible factoring words. But you do have to know that basic step there. 10, that subtracts to give me 3, negative 5, positive 2, multiplies to give me 35, that subtracts to give me positive 2.
Do you want us to say the answer? Or you just
I don't care.
talking to
You
yourself
can, you can say it if you want. Sometimes no one ever answers me, so I have to answer myself, so it's nice to know that someone answers me. See, these aren't so bad. The multiplies to give me 21, that subtracts to give me 4, negative 2, positive, no, negative 3, positive 7, sorry. Right? Yeah. And then 7 times 2 is 14, plus and plus gives me plus 9, right? And again, you might have them, like the x plus 7 first and the x minus 3, but you should have those same parentheses in the top and the bottom. You gotta admit that it's no, it's not fun at all for you to do this. I like the canceling out, it's my favorite. My favorite is when everything cancels out and you get 1. So satisfying to me. I'm like, yes, it's 1. I notice I crossed out this x plus 7 with this x plus 7, but you might have done that one. It works out the same. I can cross out this x plus 2, this x plus 2, this x minus 5, this x minus 5, and all of that gives you x minus 3 over x plus 7. And although I enjoy crossing things out, don't keep crossing out these x's and tell me the answer is negative 3/7. Right? I'm telling you, people do it every time. I have a division. Let's look at a division one, and then I'll leave you alone if we feel okay with it. The division ones look a little scarier, I think, because it's a fraction and fraction, but you always are just going to rewrite it. So I could give you something like this that at first you're like, who would do such a thing? And I'm totally okay with on your homework when this is the problem, go ahead and start with rewriting it. If you want to factor as you rewrite it, you can do that as well. I'm going to just rewrite it and then factor it since it's our notes. But like on your homework, if you want to rewrite it as multiplying by the reciprocal and factor at the same time, just make sure you're copying down the correct problem. But remember that division is the same as multiplying by the reciprocal, so I'm going to rewrite this as this. X plus 3 over x squared minus 4. And instead of dividing by this, I'm going to multiply by the reciprocal. So I'm going to take the bottom and it's going to become the top, x cubed minus 8. And this is going to go on the bottom, x squared minus x minus 12. If you just remember that first step to multiply by the reciprocal, it's exactly like the other two problems that we did. We're going to factor, we're going to cross out, and then multiply across to see what we have left. Notice there's another cube one in here. I think we did this one already earlier. But those factoring cubes are going to still show up. I have a question about this, rewriting it. So x plus 3, that's the difference of two squares there on the bottom. So it factors into x minus 2, x plus 2. Probably the cubes are the one that people are still having the most trouble with because it is just that special formula, and it is back in R5 if you don't have it written down. But this is x cubed minus 2 cubed, so it's going to be x minus 2, and then the first one squared, the last one squared at the end, and then in the middle it's just the same a times b. And I think we factored the bottom one already too. Didn't we already have this one? Minus 4 plus 3 to get negative 1 in the middle and negative 12. It's very similar to one that we did, right? So now the x plus 3's cancel and x minus 2 cancels. And on the top, we're just going to write what's left. X squared plus 2x plus 4. That does not factor anymore, so that's why we leave it like that. And on the bottom, I'm going to leave that as x plus 2 and x minus 4. So very repetitive today. Factoring, canceling, multiplying what's left. And we get to adding and subtracting, which is also in this section. A little bit more work. Got to get a comment on it. But this looks like that. Okay? So let me give you some homework, and then you can get started and let me know if you have questions. This is R7 day 1. You're going to do 6 through 33 multiples of 3.
Wow. That's wow.
I think that's 10 problems.
Thank you.
The first few are just simplifying, not multiplying, so there's not as much to do. And then the last ones are multiplying and dividing.
So, here's this is,
Yes.
so we're gonna tell you how to put exactly where it comes from.
Well, no, that's okay. You can just have your own graph paper.
Not much of this stuff.
Oh my gosh, then I will use graph paper.
Really? I don't know why.
I have also graph paper though. You're going to want to use my graph paper.
I might have been thinking about it. That's okay.
I've got graph paper that has graph and then room next to it if you work. You don't have to flip back and forth.
I should do all my own grabbing.
That works too. All right, so get started on this. So if you have a question that you can ask me, if you have a question about your